Very good morning. This is Dinakaran, working in Sri Muthukumar Institute of Technology as an assistant professor, the Department of Mechanical Engineering. Today, I am going to give a video lecture on drone technologies, CMR 332, the subject code, and the regulation is 2021 regulation. This subject comes for the Department of Mechanical as well as mechatronics and robotics and automation departments. So coming to the syllabus, unit 1, introduction to drone technology. Here the drone concept and vocabulary terminology has to be studied, and also the history of drones and types of current generation of drones based on their method of propulsion. Drone technology impact on business through the entrepreneurship as well as the employability. So this comprises the unit 1, and in unit 2, the drone design as well as the fabrication and programming. So classification of UAV, that is unmanned aerial vehicle, the complete overview of the main drone parts to be studied in this unit 2, and also the technical characteristics of the parts and the components, functions as well, and assembling a drone as well as the drone configuration and the method of programming drone. So how to download and install program in the case of drone flight modes as well as the Wi-Fi connection, how we have to introduce or fabricate in that drone design. So this is the unit 3. You can see here the drone flying and operation. So here the concept of operations for drone flight modes: a small drone in controlled environment, drone controlled flight operation, management tools and sensor, and storage capacity. And the next unit 4, you can see here the drone commercial applications. So here the drones, you can see in the various applications like the parcels, delivering mail, parcels and other cargo from one place to another place, as well as the drone in agriculture, in inspection of transmission lines and power distribution. So drone in filming and panoramic picturing also it can be used in the drone commercial applications purposes. Here the future drones and safety is the unit 5. So here we are going to discuss about the safety risk guidelines to fly safely as well as the specific aviation regulation standards. So that is the regulations, what are all the regulations need to fly. These are all in the unit 5, as well as the drone license and miniaturizations of drones, increasing autonomy of drones, as well as use of drones in swarms. That is the multiple of drones we can use. That is the drone in swarms manner. So this comprises the unit 5. So the main objective of this subject is to understand the basic of drone concept and to learn and understand the fundamentals of design, fabrication and the programming of drone, and to impart the knowledge of flying and operations of drone, and to know about the various applications of drone, to understand the safety risk and the guidelines of fly safely in condition. So the course outcome is to know about various type of drone technology as a drone fabrication and programming, and to execute the suitable operating procedures for functioning a drone. Select appropriate sensor and actuators for drones, and to develop the drone mechanism for specific applications, but also to create the programs for various drones. So these are all the outcomes for the subject. First and foremost, we can say about the drone concept. So what do you mean by drone? So it is an unmanned aerial vehicle in a small or medium sized aircraft that can fly without a pilot on board. On-board drones can be controlled remotely or operated autonomously. So drone technology refers to the aerial vehicle that receives remote commands from a pilot or relies on software for autonomous flight. Many drones display features like cameras for collecting visual data and propellers for stabilizing their flight patterns. So these are the drone terminology. Here I specified the what is the name and term and also the description about that. So first is quadcopter. So this is the most popular name for a small unmanned aerial vehicles which has four rotors positioned on a horizontal plane like a helicopter. So other names include quadricopter or quadrocopter. And multicopter, it is a generic name for a drone with multiple propellers. So this covers quadcopters as well as the octocopters. And hexacopters, this is a drone with six propellers and motors. So this offers a great stability compared to other. It has a stability in condition. So octocopters, these drones have 8 blades and offers a great stability. So RPAS is a remote piloted aerial system. So this is an aircraft that is piloted by a remote, not on board the aircraft. So UAN stand for, as you know that, unmanned aerial vehicle. This is an aircraft that is not manned. So without manned we can operate. So UAS is a unmanned aerial aircraft safe system. So this is an aircraft that is not manned. So SUAS is a small unmanned aircraft system. This is a small aircraft. And the flying terms, this is the most important in the flying terms. That is yaw, roll and pitch. As we know that yaw is in the drone movement refers the drone clockwise or anti-clockwise direction. And roll, this is the movement of drone forward or backward, left or right. That is the position of flying terms. And pitch is this is the movement up and down of the drone along a vertical axis. So these are the main parts of drones. So it consists of various components that work together to enable their flight and functionality. So major components you can see here, that is a frame, propeller, engines and electronic system control. And PDP is it is a power distribution board and a flight controller, as well as a transmitter, battery, receiver. These are the main parts to assemble the drone which can fly. And it has the modules and a rechargeable battery, flight control board and RF transmitter and receiver modules. So parts of drone as we discussed. So these are the parts you can see here. So control, receiver and antenna and FPV camera, as well as ESC, that is electronic speed controller, is the main component. So these are the classification drone. As I said, that multi-rotor drones which have multiple rotors, and as well as the that is impeller blades, like that. And the fixed wings, we have a fixed type in the front. We can see here the fixed wing drones, and a single rotor drone, and a fixed wing hybrid uh, drones are we can design. So single rotor helicopter drones, these drones have a single large rotor and are often used for heavy payload transport, as well as research and military applications. So that the single rotor helicopter drones, they have long endurance, can however and take off vertically. So multi-rotor drones, these drones have multiple rotors, including quadcopters, hexacopters, and octocopters. These are easy to control and maneuver, and are often used for photography, inspection, as well as the recreational flying. So fixed wings drones. So these drones have airplane-like design, and are often used for mapping, surveying, and long-range monitoring. So they have a longer flight times and can carry heavier payloads than multiple rotor drones. And coming to the fixed wing hybrid vertical, that is VTOL, that is vertical takeoff and landing drones. So these drones combine a vertical off and landing with efficient forward flight. So they are versatile and can be used for surveying, mapping, and research and rescue, like that. So drone configurations have a variety of applications in our daily life, so that have attracted and attention of many researchers around the world. So there are variety of innovations in the flight mechanisms, that UAS, that is unmanned vehicle systems, are applying for flight. So there is also significant interest in the development of new types of drones that can fly autonomously in different locations, such as city, marine, and space environments, and perform various missions. The different configurations here, the flight mechanism, we have VTOL and HTOL, that is horizontal takeoff landing, and vertical takeoff landing, and hybrid and bio-based drones. So this is the level of autonomy as we discussed in the flying terms. Here a pitch, yaw, and roll. So the direction is a vertical direction is the yaw position, and the horizontal, and we have a lateral pitch, and the roll is the longitudinal directions, which have flying terms, as well as the level of autonomy here I have shown here. And this is the drone design. So we can use all the parts and fabricate like this. We can see here the camera, and then the propeller. So this is the four rotors, 1, 2, and 3 and 4. We have 4 motors, and we have here the mechanisms and various engine speed controller we have designed in centrally, and the camera here, the capture from here. This is the drone design, and this is the propeller blades. is an aerodynamic device which converts rotational energy into a propulsive force, creating thrust which is approximately perpendicular to its plane of rotation. You can see here the blade design here, which is velocity gradient. We can see here the velocity gradient, which is the thrust downwards force, can lift the drone forward or upright, the top. So this is the brushless DC motors or electronic switching engine. Here the main parts you can as in the previous slide we have seen that this design are they are fabricated, that is BLDC technology or brushless without brushless DC technology, that is BLDC. It's a type of electric motor that uses electronic communications instead of brushes to operate. So BLDC motors are more efficient and reliable than traditional motors. So this is the overall view. You can see here the electronic speed controller which is fitted here. So these are the different there is propeller which is connected with the ground, and it is a throttle sensor, and here the rotor position, and this is the motor as well as connected with the battery terminals. So overall view here, that is a traction and control system, electrical system. We have designed here the electrical system which have the servo control with the mechanism, and the battery which has run by the electronic speed controller here is fitted with the through the servo control, and the blades or propellers are fitted here through the motor. It can run so that we can easily fabricate the drone. So traction and control system, this is the design. You can see here the left, right and rear, front through the electronic speed controller. We have here designed like that internally to flying purpose. So this is the sensor board here fitted here, so that we can design easily in the drone technology and applications wise. So this is the power distribution board. As we know that the power from this board we can directly go and sense the sensor to operate. So this is the power distribution. So this is the overall view. You can see here how the drones are designed through the microcontroller. The signal goes to the motor driver, that is motor 1, 2, 3 and 4, and again it is goes to the propeller. So blade is 1, 2, 3, 4. So likewise these are the software as well as this is the hardware. Can show specifically here shown the motor here and impeller or blades. So this is the motor which is designed and designed with the ESC, that is engine speed controller here. This is the drone design. So thank you for the watching this lecture video. Thank you.